Hello everyone, welcome to Career Nub courses. This course will give you an introduction to SQL. This is especially for people who want to learn SQL from scratch. This does not require any prior knowledge of any coding language. Let's begin. Introduction to SQL. Here's what you will learn in this course. Basics of database, creation and deletion of tables, selection and filtering, aggregations and grouping, and then finally sorting. A quick intro about me. I'm Utsav Shah, co-founder of CareerNub based in San Francisco. I'm extremely passionate about data science and product and have worked in the consumer internet industry for more than 6 years. All right, basics of database. What is a database? A database is something which stores sets of data that can be queried for use in other applications. And one of the strongest applications is analytics and data science. A database management system, it supports development, administration, and use of these database platforms. The specific database that we are going to talk about is relational database. An RDBMS, or a relational database management system, is one that stores data in a row-based table structure and which connects related data elements. Most common means of accessing data from RDBMS is structured query language, or SQL in short. Here is how a typical table structure looks like for a RDBMS. There would be a bunch of columns and then there would be a bunch of rows. Right, a quick setup and installation guide. For this, we're going to use two softwares. This is a very easy installation process. One, we're going to use Postgres. PostgreSQL is a powerful open source object relational database system. You can click here to go to the download page, and this is how it looks. Choose the OS of your choice and then download and follow the installation guide. Second is pgadmin. It is the most popular and feature-rich open source administration and development platform for Postgres. You can click here to download. Again, choose the OS of your choice and then follow the setup and installation guide. Now let's open the application. So as soon as you open the application, it will ask you to type in the password that you set for pgadmin. Once you do this, you'll see this dashboard. If you click on the server, it will ask you to connect to the Postgre, and you have to use the password that you set up for the Postgre. And we are live. There are two learning paths for this course. One is the hands-on approach, which is the recommended one. So you download the code with me file and copy the content in the pgadmin's query editor. You will watch the video, learn, code, and run the results yourselves. So let's do that. Copy all the things and start a new query editor and copy the contents here. The second approach is more laid back. This is not recommended, but if you're in a hurry or you already know some of the concepts and you just want to revise, then you can download the follow along with code file and copy the content in pgadmin's query editor. You can watch the video and then run the ready-made code that you have. All files related to this course is accessible via this folder. A quick look about the dataset itself. It's an extremely interesting dataset. This data contains transactional level information about an e-commerce website. The data has close to 400,000 rows and 8 columns, and the following are the details of each column. You have the invoice number, which is a 6-digit number uniquely assigned to each transaction. You have the stock code of each product or each item, which is again uniquely assigned to each distinct product. You have the description of the product. You have the quantity of the items which were sold. You have the invoice date, and this includes the date and time of each transaction. You have the unit price, or the per unit pricing of the product. This is in sterling. You have the customer ID, or a unique ID, which is given to each customer. And then you have the country. It's the country name or the country where each customer resides in. You can click here to get the details of the entire data set and the first 1,000 rows of the data. All right, to access this data, download this CSV. And then we'll move to PG admin to do rest of the stuff. All right, let's learn about creation and deletion of a table. Now here we're going to delete the table even before we create the table, and I'll explain why we do that. So the command for that is just drop table and the table name. In this, I'm just going to mention our table as e-commerce underscore data. Every block of code is followed by a semicolon for it to get executed. You can either click this button, which is run, or you can just do F5. It says it ran, and you can just hit F5. So now here, observe that there is an error which says table e-commerce data does not exist. So now what we want to do is have the system check whether this table exists or not. So drop table if exists, only then delete it. Now let's hit F5. So now that error has turned into a notice saying table e-commerce underscore data does not exist, and hence it's skipping this line. Okay, let's see how we create a table. Very similar to how we delete or drop. Just write create table and then the table name, just e-commerce underscore data. And now we have to define two things. One is the column name. So in this case, it would be invoice number, the first column, and then the column type, which is variable character in this. There are more column types, which are timestamp, big int, numeric, variable character, array, or JSON. You can learn more about these column types on this link. Now let's create all the columns in our database. So we have the invoice number, we have the stock code, which is again a variable character. We have the description of the product, which is varchar. We have the quantity, which is a numeric column. We have the invoice date, which is a timestamp because it contains both date and time. We have the unit price, which is a numeric column. We have the customer ID, which is a big int because it only contains integers. And we have the country, which is again a variable character. Let's check invoice number, stock code, description, quantity, invoice date, unit price, customer ID, and country. Right, semicolon, and let's run this. Okay, it says your table was created and the query was successfully run. Okay, now to get the CSV that we downloaded, which is e-commerce underscore data.csv, how do we get this into the table that we just created? Now we are going to follow a series of steps. On the left panel, click on the server and right click and hit refresh. Go to databases, then to schemas. Under the publics folder, you'll find tables. And here would be the newly created e-commerce underscore data. If you don't find this, just right click on the table and hit refresh, and you will be able to see the newly created data. Click on the e-commerce data, click on import export, make sure that you hit the import button. In this, let's navigate to the e-commerce underscore data.csv. The encoding that you're going to select is ISO 8859_5. Also tell the system that it has headers in it. The delimiter would be comma because it's a comma separated file, and just hit OK. Perfect. So it says successfully completed. If you click the more details, it will say it has copied all the rows in our table. Okay, let's SQL. The first task is selection and filtering. Now, how do we get all the data? Let's look at that. The first question is get the first 100 rows of the data set. Now here I'll introduce to three core concepts. To select the columns, we use the select command. To define which table to access, we use the from command. And to limit the number of rows that we want to get, we use the limit command. So in this case, we are selecting all the columns, which means just star. So if you define star, it means you will get all the columns within the table. From, we'll just mention our table, which is e-commerce underscore data. And then we want to limit it to the first 100 rows, which means limit 100. And let's put a semicolon. Cool. Let's run this. Okay, so now you see that you have the data set, which is invoice number, stock code, description, quantity, invoice date, unit price, customer ID, and country. If you scroll down, you will see that you only get 100 rows of data. Perfect. But not all the time you need all the columns. So what if you want to get specific columns from this data? So the question is, get the invoice date, invoice number, the stock code, and quantity from the data set, and also restricted to the first 100 columns. We use select for selecting the column names. What column names do we want? Invoice number. Each column is separated by a comma. So we want the stock code. We also want, invoice date, invoice number, stock code, and quantity. We want this all from the e-commerce data. And we also want to apply a limit to the amount of rows that we get, which is limit 100. Let's run this. All right, so now you see that we got the invoice date, the invoice number, the stock code, and the quantity, because these were the columns which were defined in the query. We get this from e-commerce data, and then we can also put in a limit of 100. All right, this is a very, very important concept in SQL, which is named aliasing. You can use the as function to define and use aliases for table names and column names. So here's the question. Get the invoice number, the stock code, and quantity from the data set, only the first 100 rows, and output the quantity column as units sold. Okay, we know the drill. Select invoice underscore number, stock underscore code. We want to get the quantity, but we want to rename this quantity in the output that we want, and hence we can use as. So as, we can say units underscore sold. We want this data from e-commerce underscore data, and we can rename this table as well, saying ed, and we can limit all of this to just 100 rows of data. Okay, let's run this. Perfect. So what you see is that you can alias table names and column names. So table name e-commerce data, you can refer that to ed, and the quantities column, you can actually change that to units sold. You can change all the columns or any columns that you want as per your liking, and you can use the table aliases as well further in the query. We'll see how this is extremely useful in writing a very, very clean code. Okay, let's learn about filtering or conditional filtering. We can actually filter the data using different conditions. And the command for that is the where function. Let's look at some of the examples of using single conditions. The first question is get all the data from the country France. So all the data means you have to select all the columns. Select star, mention the table, which is e-commerce underscore data. And we'll use the alias ed. And we have to use where. So where the column name, which is country, is equal to, and then the input, which is France. Okay, let's run this. Okay, here you see that you have all the data or all the rows from France. Very similar to this, we can see how we can get data from multiple countries. So the question is get all data from these countries: France, Netherlands, and Germany. So let's write select star from e-commerce underscore data. where the country, and to select multiple things we can just mention in, and then in the brackets you can mention the different variables that you want or inputs that you want. So we want France, we want Netherlands, and we want data from Germany. Put a semicolon and let's run this. Perfect. So now you see that it ran this, and you'll see that it has the data from Germany, France, and Netherlands as well. What if you want to get data from all the countries except one of the countries? So let's see how we can do that. So select, get all the columns from e-commerce data, and now we are going to use where country, and now the country should not equal to United Kingdom. Let's run this. Perfect. So you get all the countries, which is France, Australia, Germany, and tons of other countries, but not United Kingdom. There's another way to write this. So instead of this, and you can just comment, you can write where country is not equal to United Kingdom. And let's run this. Perfect. This also gives the same result. There are a couple of functions that you can use for not equal to. Okay, let's see how we can get all the data where customers bought items whose unit price was more than 20. Okay, so let's see this. So again, select all columns from e-commerce data. Now we are going to mention where unit price is greater than 20. And let's run this. Okay, so now if you look at the unit price column, it has filtered all the rows and given only which are above 20. You can use most of the operators or conditions that you want, which is greater than, less than, greater than equal to, not equal to, all of those things. Okay, let's see how we can apply multiple conditions within the filter. So first we saw only a single condition applied to the filters, and now we'll see how we can get multiple conditions in this. Okay, the first question is, how can we get all the data for expensive items? And the expensive items, the definition is just unit price greater than 20 in France. And here we'll introduce you to the AND operator. So select all data, which is star from e-commerce, where the unit price, first of all, is greater than 20, and the country is equal to France. And semicolon. Let's see. Perfect. So we get all the rows, and there are only 5 rows. This gets the data from France, and where the unit price is actually greater than 20. Let's look at another operator named OR. So what if you want to get data for items which are either expensive or their quantity is higher than 20? Perfect. So let's select all columns. Now where is expensive, so which means unit price is greater than 20, or the quantity is greater than 20. And let's run this. Perfect. So you see how we get either the quantity, which would be greater than 20, or in some cases the unit price would be greater than 20, like this. What if you want to get all the data for items which are in the price range of 20 to 25? Okay, so what we can do is use select E. Now let's look at where. So unit price has to be greater than equal to 20 and unit price has to be less than equal to 25. Let's run this. Perfect. So we get all the rows where the unit price is between 20 to 25. However, there is a much more logical way to write this, which is using the between operator. So let's comment this. We can just say where unit price is between 20 and 25. And this will include both 20 and 25 in the condition. Let's run this. We see 211 rows and the same number of, so exactly the same data set. So it's better to use just the between operator. The following question is get all data with expensive items in France and higher quantity in Germany. So now this will involve using both the and the or operator. Let's look at how we can do this. So select data as empty, where expensive items in France, which means the unit price is greater than 20 and the country is equal to France, and let's put a condition on this, or we can say the quantity is greater than 20 and the country is equal to Germany, and let's run this. Perfect. So you see the columns where there is Germany, it says that the quantity is higher than 20, and for rows where the country is France, the unit price would be greater than 20. Now you can use the or, the and any other operators that you want and put in as many conditions as you want within the where function to get the kind of result that you want or to filter your data. Let's look at some of the math operators which can be performed here. So the question is get the invoice number, the stock code, the quantity, the unit price. This is all we know. And it says to also get the revenue, which is defined as quantity times unit price from the data set. And it says get only the 100 rows. Okay, so let's do the easier stuff first. So select invoice underscore number. We also want to get the stock code, get the quantity, the unit price, and now it says we have to get the revenue, which is quantity times unit price. Okay, so what we can do actually is just do quantity star unit price, and we can rename this column as revenue. We have to get all this data from e-commerce underscore data, and then also only get 100 rows of data. Okay, let's see how this performs. Perfect. So now we have an additional column which says revenue, which is actually a mathematical operation between two columns, which is quantity and unit price. You can learn more about mathematical operators in this table, and you can perform all kinds of mathematical operations between each columns. So you can square the columns, you can multiply the columns, you can divide the columns, etc., etc. Now there's a very important concept named aggregations and grouping. Some of the aggregate functions are sum, count, count distinct, average, max, or min. More general aggregate functions can be found on this link. Okay, the first question, get the total rows in the data. So we can do select, and now we even want to get the total rows, which means we have to count all the rows. To do all, we know that we have to use the star function. To count, we can use the count function. So let's combine both. Count of star. Now we want to get all data from e-commerce underscore data. And let's see how this performs. And now we have the total number of rows in this data set, which is 396,370. Let's also rename this column as total rows. Let's also rename this column as total rows. And we'll run this again. Perfect. Okay, second question. Get the total number of distinct customers in the data. Now, there are three things. We have to get the total number. So we have to count. We have to get the customers, which is by customer ID. But we have to do a distinct count, which means distinct customer ID. And let's rename this column as total distinct customers. From this, let's run this. Perfect. So there are 4,335 total distinct customers in the data set. Let's get the total number of items which are sold. Now, items sold is just quantity. So let's do select, and to aggregate or get the total number, we'll do a sum, because this is quantities. So sum of quantity as total items sold from e-commerce underscore data. Okay, let's run this. Perfect. And we see that there are more than 5 million items which are sold. Let's see what is the maximum, minimum, and the average of unit prices for these items which are sold. Okay, so we have to get the maximum, which is using max function of the unit price. We'll rename this as max unit price. We also have to get the minimum, so minimum of unit price. And we also have to get the average of this unit price. We have to get it from the same data. Let's run this. Perfect. So what we see is that the maximum unit price is 650. The minimum unit price is just 0. And the average unit price is 2.86. And there are a lot of decimal places. Now, let's see if we can get some of the statistical aggregate functions. So the question is, get the variance and the standard deviation of unit prices for these items which are sold. So again, we can use some ready-made function, which is variance of unit price we can get the standard deviation, and we have to get everything from the same data. So run this. Okay, so we see that the variance of the unit price is around 18 sterling, and the standard deviation for this is 4.2 sterling. So now you see that the output of this is not as pretty as we want. What we can do is use the rounding function. All right, let's see what the rounding function does. So the question is, get the variance and standard deviation of unit prices for these items, which is just as same as above, and output just 2 decimal places for these. Okay, so let's go to the drill, select, we'll do variance of the unit price, and we rename this as variance of unit price. However, what we want to do is round this entire function. So round this to just 2 decimal places, and we'll see how the output looks. So round, we want to get the standard deviation of unit price, and we have to restrict to 2, and rename this column as standard deviation of unit price. from the same table. Okay, let's run this. Okay, so now it's much more readable. We have the variance and the standard deviation in two decimal places. All right, so we just learned about all the aggregations that you can perform. How about grouping? What does group by mean? So group by, this provides pivot table-like functionality through SQL and is extremely useful to perform analytics. The first question is, get the number of distinct users by each country. So by now you would know how to get the number of distinct users, which is, so select, and you can count, remember, distinct customer ID as distinct total distinct customers. We can get this from the e-commerce data. Let's run this. What we saw is the earlier result. However, there is an added question in this which says we want the total number of distinct users or customers, but we want this by each country. So now let's introduce the concept of grouping. So let's do country. So we want the number of distinct users by country. So we have to get the country column and also the number of distinct customers. And we have to tell the system that we have to group it by the column country. Okay, let's run this. So this is great. So we get now a table which is by country, and it counts the total number of distinct users by these countries. Now let's do a very similar exercise. The second question for this is get the total quantity sold and value of items sold by each country. Okay, so let's do select. We want this by country. So now we know that we have to include this column. We want to get the total quantity sold, so which is just sum of quantity as total quantity sold. And we want to get the value of items sold by each country. The value or revenue, we have seen how you can get this. So we have to sum the revenue column, which is nothing but quantity times unit price. And we'll rename this as total revenue. We have to get this all from the same data. And we have to group this all by the country column. Let's see the output for this. Perfect. So now we know in each country how many items were sold or the quantity of the items were sold and what was the revenue for each country. Great. Now there's an interesting concept called numbered aliasing. So in all of the group bys, we don't need to mention the column name every time. What we can use is just index of these column numbers. So let's look at the same code again and see how this performs. So select, we have to group it by country. We have to get the quantity as total sold, and we have to get the revenue, which is quantity times unit price. And we have to get this from this data. Now we can just do group by and the index of the column. We have to group by country, which is the index 1. So we'll just mention group by 1. Let's see how this looks. Okay, there's an error. Price. Let's run this again. Perfect. So we see that the same query works as well by using numbered aliasing. This becomes an important tool when you're writing a very, very long code. You can just use numbered aliasing to not mention the column name again and again. All right, last concept for this lesson, which is sorting. This is extremely important when you want to sort different columns and look at the results as you want. We can use the order by functionality for this to sort the final results based on the column that you mentioned. So let's look at the question. The question is get the total quantity sold and value of items sold by each country and sort it by the lowest quantity sold. Okay, this is the same code as above. Okay, Now, instead of ending it at group by, what we want to do is order by the data set, and the column that we want to do is total quantity sold. Let's run this. So now you see that the entire table has been sorted by this column, which is total quantity sold. Let's look at how we can sort descending by a descending manner, and we can use DESC for that. The question is, get the total quantity sold and value of items sold by each country and sorted by the highest quantity sold. So instead of the lowest quantity, we want the highest quantity sold. Okay, let's copy the first part of the code, which is same. So select by country, you want the total quantity sold and also the revenue. Make sure that you're grouping by the country, and we'll use the order by functionality for this. Mention that we want to order by total quantity sold. However, what we want to do is do this to make sure that it's sorting in a descending manner. Okay, let's run this. All right, so now you see that United Kingdom has the highest quantity which is sold, Netherlands followed by that, and so on and so forth. Let's look at one interesting use of the sort and limit together to solve some of the business problems that we can get. So what if we want to get the top 10 countries with the highest total quantity of items which are sold? And let's see how we can do that. So let's do country. Let's get the quantity sold as total sold. We have to get this from e-commerce underscore data, alias with ed. We have to use group by country, and then what we need to do is order by total quantity sold, and because we want the highest total quantity, we'll just sort it by descending. And at the end, we only want to get the top 10 countries, which means that we can limit this data to just 10 rows. And let's see how this performs. Perfect. So now we have the top 10 countries with the highest total quantity sold of items which are sold. All right, thank you so much for taking on this course. Here's the concepts that you learned. Basics of database, creation and deletion of tables. We looked at how you can select and filter. We looked at how you can aggregate and group. And lastly, we looked at how we can sort the data as well. Thank you everyone again, and I'll see you in the next lecture.